Hello and welcome back to another fabulous episode of Constellation Crew. I am so excited. You could tell probably because I'm all jittery this morning, but we have a lot to talk about today and I'm just so excited for all of you to be here today. So of course we have our usual Constellation Crew with me, Nicolette, as the host, and my two crewmates, Kenya and Kyree. Say hi, guys.
Hey.
And for our most observant viewers today, you might have noticed that we have another crew member today. I would like to introduce you all to our special guest, Dr. Todd Vaccaro. Say hello.
Hello.
So, what is your relation to Ball State, Dr. Vaccaro?
I'm a professor of astronomy, mostly teach astronomy, a teaching assistant professor. Been here for about 3 years now.
Awesome. I've had him in a couple of classes, viewers, and can highly recommend. So we are facing south here in Stellarium, as per usual. If you guys watched our last episode, we have our little teapot friend, little lid and spout here in the south with us. We also have a bright neighbor that constantly orbits the Earth, our moon here. Can anyone on the crew tell me what phase the moon is in right now?
Do you want to take it, Kenya, or should I?
You can take it.
Unless I'm horrible with my astronomy knowledge today, I think it should be in waxing gibbous.
Yes, that is correct. Waxing gibbous. Very funny name, but that is one of the proper terms when addressing the phases of the moon. We have waxing gibbous today. There's also a waning gibbous, but it is in waxing right now. So, that being said, can anyone here tell me if the moon is heading to a full moon or a new moon? Based on the phase.
I think it's heading to a full moon.
Yes, it is heading to a full moon. Our Planetarium show specialist, Melanie, frequently uses this neat trick, and I really like it. It's called, or the phrase is, light on the right, getting bright. So Kenya is correct. It's heading to full because the light is appearing on the right side of the moon, going right to left. It's getting bright from right to left. So that being said, the opposite is if the light is on the left, it's going to new moon. So cool. We have our moon in the sky tonight. Aside from that, so getting into the good stuff of our program today, one of my favorite things about astronomy is that sometimes you can say something that was done in astronomy completely out of context, and it sounds not so scientific. And just recently, we crashed a spacecraft into a giant rock in the asteroid belt. Yay! We love crashing things into rocks. So for those who don't know, I'm actually talking about a special mission called DART. DART stands for Double Asteroid Redirection Test. Very big phrase, right? So does anyone on my crew know anything about DART and why DART is called that? No? Feel free. So DART is basically, we did crash it into a rock. However, it's a very important rock, also known as an asteroid. So DART was launched and sent to a double asteroid system of names of Dimorphos and Didymos. So Didymos is a bigger asteroid of the two, and Dimorphos is orbiting that big asteroid. And DART was sent there to crash into Dimorphos to try to see if it could change its orbit. All in all, this was just a big test in planetary defense. So we all know that we would rather not an asteroid too big come to Earth and break through the atmosphere, because the dinosaurs know what happens when that happens. But we don't want that. So this was a big test to see if we can ever prevent that from happening for us, because we currently are trying to find the technology in order to protect ourselves from really big asteroids out in space. So that was kind of the point. We are still waiting on the results to see if DART did make a significant change in the orbit of Dimorphos, sorry. So Dimorphos is the smaller one, so we're trying to see if that changes. We're still looking on that because it takes time. It's not an immediate change. We have to wait and see, but observations are being held. I don't know about you all, but I was with Dr. Vaccaro and some other faculty and student members the night it happened on September 26th. We watched it live, and it was a beautiful thing to see. Where were you guys, crew, when on September 26th? It was around 7:15 p.m. when Dart crashed into Dimorphos. So where were you guys?
Honestly, I was just in my room.
I was home.
I
You were
was
home?
Sorry.
in my room.
You were in
I
your
was
room?
Yep.
Did you get to see it live? Did you see it in your room?
No, I was pretty sure I was taking a nap at the time.
Okay.
He slept
Yeah,
through
I
it.
didn't get to see it happen. I didn't know it was like a thing, but I ended up seeing NASA post about it on Instagram, which is how I found out about it.
Very good. Yeah. Awesome. I'm really glad you got to see it at least.
It's also pretty funny when you look it up on Google. There's this little like animation where you scroll down. They send a spacecraft into the Google website, and it like blows up halfway through, and then it disorientates the whole search. It's
Google
really weird, but it's funny.
is amazing for that. Thank you for sharing that. I did see that the other day, and it's so funny. They do that similar to Friends. If you look up certain Friends characters, there's a little icon next to their name in Google, and it makes funny little changes to the so I think if you look up Ross, there's a couch, and you hit the couch and it says pivot in Ross's voice, and it's really funny. So that's exactly what Kyree is talking about. Highly recommend our viewers, if you didn't get a chance to see it live, like Kenya said, NASA and other places of science have been posting about it, posting shorter videos, or you can watch the really long one, I believe, because it was live on YouTube, and usually YouTube lives are posted as videos later on. So that's how Dr. Vaccaro and I and other faculty and students were able to watch it. It was on YouTube Live. So feel free to check out some videos. It's honestly an amazing thing to see, especially if you watch the full one, which is kind of long.
Yeah, we started watching that, an hour and a half before impact?
Exactly. So we got to see it as a tiny little speck on this green screen because there was a camera on the spacecraft. So we actually got to see it get bigger and bigger and then crash. So
yeah, that's the first impact where they actually had a live camera going in.
Yeah, and I will say it was a really nice camera. I mean, when you got real close, you could see so much detail. I was really impressed. I did not think that NASA would be that nice. But considering it was going to crash into an asteroid. However,
so I'm curious if anybody knows what kind of observations we take of that system to know whether or not we change the orbital period.
Right.
Anybody know?
My guess.
Nicolette, you should know.
So my guess would be, in terms of like exoplanets, one of the ways of discovering an exoplanet is seeing the change in radial velocity. That's a big word, but to simplify it, a star tends to wobble, and when it wobbles, it changes in terms of wavelength and color, brightness, maybe. Correct me.
So you're talking about Doppler effect?
Yes.
But this one actually has an orbit that's in the plane of our line of sight. So what happens when one passes in front of the other?
Oh, it eclipses.
Yeah. It's an eclipsing binary asteroid.
If it changes the orbital period, it'll change its eclipsing period. Yeah. So I do research with Dr. Vaccaro, and we do binary star systems. So when we are talking about the period of the system, so Earth orbits the sun in 365.25 days to be exact, but 365 is the number we are going to talk about. That is the period of the sun. So when you say the period of something else, it's just how long it takes that object to orbit something else, whether that's an asteroid, a sun, a planet, whatever that case may be. So we'll be able to check that out when it eclipses the asteroid.
So that'll take a couple months of data.
Exactly, it'll take some time. That was not the only thing that was going on September 26th. There was actually something really cool going on with a certain planet in our night sky, and I believe Kenya knows some stuff about it. What do you know about our planet in the night sky on September 26th?
Yeah, so on September 26th, Jupiter was in opposition. If you're anything like I was a little bit ago, you probably don't know what this means. But opposition happens when an astronomical object rises in the east as the sun sets in the west. And that places the object, or in this case, it would have been Jupiter. It places it closest to Earth in their orbits around the sun. So Jupiter's opposition occurs every 13 months, and when this happens, Jupiter appears larger and brighter than it does at any other time of the year. But Earth and Jupiter don't orbit the sun in perfect circles, which means that these two planets pass each other at different distances throughout the year. So on September 26th, Jupiter made its closest approach to Earth since 1963. And at its closest approach, Jupiter was approximately 367 million miles away from Earth. However, when it was the farthest away from Earth, it was approximately 600 million miles away. So as the night begins tonight, we'll find Jupiter beginning in the east and moving south and towards west throughout the night. And to find Jupiter, you can look in the eastern sky after sunset, and it should be the brightest object there besides the moon. A second way to be sure that you're looking at Jupiter is that when you look at any star, they tend to twinkle quite a bit, but planets don't really. And during this time, Jupiter appears to be one of the biggest and the brightest objects in our night sky other than our moon.
Wow. Very interesting. I always love big numbers, especially when in a lot of astronomy classes, we usually use special units. We use different units, so like meters and kilometers and centimeters, stuff like that. So when we put it in terms of miles, it helps me understand just a little bit better. So that's actually pretty cool. I was able to observe Jupiter that night. I was able to convince another professor in the department, Dr. Bob Barrington, to open up the rooftop so that we could take a look, and it was a beautiful sight. But exactly like Kenya said, you're gonna look more towards the east, and then it's right in between east and southeast here, and you go right up, and I pointed it out earlier, but again, here is Jupiter. And it really is just a very bright object and very by itself at this time. Remember that in Stellarium, we are putting it just after sunset here in Muncie. It's not an exact night sky, but it's pretty darn close. So this is roughly about where Jupiter will be about after sunset here in Muncie, exactly like Kenya said. Thank you very much. Mm-hmm. So fun fact, a lot of stars and a lot of things in our night sky go on a certain path. So of course we know, like Kenya said, that our planets are going to rise in the east and set in the west, but they travel along this imaginary line in the sky. Imaginary meaning it's not up in the sky, kind of like our little directions here. They are not big S's and big SE's on our horizon in real life. So this imaginary line is called the ecliptic. To be more specific, the ecliptic is the apparent imaginary path that the sun makes in the night sky throughout the year. So Jupiter and Saturn travel along this similar path as well. That's where the sun is. And of course, that's where our zodiac constellations are. So when I say zodiac, some of you may be familiar more with zodiac sign. That is a part of astrology. Here at the Planetarium, we mainly talk about, study, interact with astronomy. However, that doesn't mean that these zodiac constellations are not important. In fact, they are and are used frequently in astronomy and are still a part of the 88 official constellations that we know. But there's one in particular that we want to talk about today, and it is called Aquarius. And I'm going to pass on to Kyree here while I try to pull that up because
Aquarius should be like somewhere in like the southwest if I recall correctly.
Okay,
and
southwest. But we're still going to at least.
Of course. And this is going to be like a sort of callback from actually the last Constellation Crew where I was talking about the Summer Triangle. Oh wow, I guess it's southeast. I must have missed it that. But when I was talking about Aquila during our last show, I talked about the eagle that carried Zeus's thunderbolts, and also took Ganymede to Mount Olympus to serve as cupbearer. Well, that is actually what Aquarius represents. Aquarius is Ganymede, the what Homer would describe as the lovely boy born amongst mortals, and was taken to Mount Olympus to serve as the cupbearer for Zeus' probably own pleasure. But if we just move a little bit past talking about Aquarius specifically, more than just it's being a special zodiac constellation, there's actually something really interesting that we discovered a couple years back, and it is actually an exoplanet called HATS 72b. What's really cool about this exoplanet is that it's actually a gas giant that orbits around orange dwarf, which is like a smaller type of star that's in between like red dwarfs and yellow and stars that are similar to our own sun.
Yeah, and orange means it's cooler, right? It's a
orange
cooler
means
star.
it's on the cooler spectrum. Yes, that is correct, Nicolette.
Okay.
In terms of distance, it's like 416 light years away, and to put that into more understandable terms, it's about 6 trillion miles per light year. So that's a road trip I don't ever want to complete in any of my lifetime.
Wow. I think I like the light years number better, but okay.
And that's only for every 1 light year. So I'm
goodness.
Gonna hold back on that one. But a really interesting thing is that its orbit around the star that it's orbiting around, I don't know why I said that, is only 7.3 Earth days.
Days?
Days.
Wow.
Yeah, whoa.
Wow. Okay then. That's really small. I deal with small orbital periods as well when we talk about binary star systems, but a planet, 7 days?
Yep.
Wow.
Only 7 days. And if we take that in comparison to Mercury in our own solar system, even though it's so close, it's still an 88-day orbit. So
Wow.
That's incredible.
Yep.
So that must make it pretty hot, right?
Yep, it is.
That's interesting. Considering that it's a gassy giant or a gas giant typically forms farther out from its star because it needs to be cold enough for gas and ice to form in the first place.
Yep.
So, wow. Must be
And
really
then,
hot.
to roll back on that term, we both use gas giant. Does anyone have a idea on what that means? Maybe even to our guests?
What, a gas giant in general?
Mm-hmm.
Well, basically looking at something like Jupiter, like Saturn, any of the outer planets really are all gas giants. They're typically, significantly more massive than the Earth, but they're predominantly just gas. So they're all atmosphere.
Yep.
They might have a rocky core somewhere. We still don't really even know what the structure is, other than mostly, just gas. So in some ways, you can think of gas giants as objects that were forming out of the gaseous nebula out of whatever solar system was forming at the time, and it didn't have enough to become a star itself. And so it just stabilizes as a big ball of gas. As far as like the oddity of the fact that you've got something in so close to the star, this tends to be what you see in a lot of these exoplanets. Part of it is that they're the easier ones to find. All the different methods that we use, you typically find those first. And so why they're there, like you said earlier, it's hard to believe that they would form there because it's too hot. And I think the expectation is that they probably did form further out, and these star systems or planetary systems actually migrated the planets around and migrated closer. There's a way through sort of all the fancy physics that exists that you can exchange sort of orbital motion between planets, and they jockey around for positions, and you might fling some out and move some in, and next thing you know, you've got a hot Jupiter.
Yeah.
Yeah.
And some rogue exoplanets. Rogue exoplanets have do not have a host that they orbit around. They kind of just travel the galaxy by themselves, which makes them very hard to find. But yeah, I guess if Jupiter and Saturn didn't agree with a certain planet, they were like, get out, go away. Whee! That was very cool. So aside from the fact that exoplanets are just awesome, I love exoplanets, they're one of my favorite things to talk about, there's something very special about this particular exoplanet. And I believe Dr. Vaccaro has a group here at Ball State that is dealing with this exoplanet. Can you tell us more about it?
Sure. That's we've got a group, basically our astronomy club, which is sort of a loose collection of students and faculty in our department that are just interested in astronomy. We do all sorts of activities, but right now our primary goal is to work with the International Astronomical Union, the IAU. And this is actually a third round of sort of a contest that they're running. They started in 2015, and then there was another one in 2019. And so now this one has got the name of Name Exo Worlds 2022. And so we've got about a month, I think, to come up with some potential names to some exoplanetary systems that they have a list. And so I think this current list, there's like 19 stars that have planets, and they're all in different areas of the sky, so different constellations. And this particular planet that we just highlighted is one of those candidates that you can come up with a name. They want names for the star, and they want a name for the planet. So instead of calling it Hat whatever B, which is basically that lowercase b is what you call the first planet discovered around that star. So the star has basically the same name, just no B. That's kind of a boring catalog name, right? So they're trying to come up with, engage non-scientists and scientists as well, bring people together globally. It's not just a United States thing, so it's an international effort to come up with some interesting names. So my experience with this is I was fortunate enough when I worked at a different institution to submit a name for the first contest in 2015. Now, in that particular contest, they had some ground rules, but they weren't very restrictive. You could pretty much come up with any sort of name. They wanted you to come up with something that was maybe connected with the constellation or had some significance that you could tie in. They didn't want you just to name it after your dog or something like that. I mean, if I had my way, I would actually have wanted to name something after my favorite robot, right? And I don't know if you can see him with my screen on, my Tom Servo robot from Mystery Science Theater 3000. But I can't do that. Those rules wouldn't let me. So,
that makes sense.
Right. So the idea there was a little bit not as restrictive. So I was fortunate enough to submit a name for a planet around a star called Fomalhaut in the constellation of Pisces Austrinus, which is the southern fish. But it's a tough thing to see. But the star itself is actually naked eye, and the planet I named was Dagon or Dagon. And so, it was associated with a fish. And so Dagon is an ancient Syrian fish deity. And so it hadn't been used before. That's another important key characteristic of these contests. It has to be a newly used name. Down, that looks like it, probably it right there. So, and so there were 20 systems in that contest that had planets that were named. And that went to a website, and they just basically voted on it globally for a matter of a month or two. And then they declared the winners at the end. And so that name won. So I basically got to name an exoplanet, which was, really cool. So this time around, 2022, Name Exo Worlds, the ground rules are a little bit more stringent. They're basically saying that they want like basically every country to come up with a name for the star in the system that is connected to each other in some way. also in a way that perhaps it's open to the same theme if perhaps they find more planets in the same system, so that they don't have to come up with a whole new original name. They can kind of go with the theme. And they want the theme basically to be connected to a location of historical or cultural significance.
Okay.
So it really kind of puts the confines on, we've got to basically come up with some interesting cultural, historical locations that we can sort of name things after. There's also a push on using indigenous languages and things like that in the naming. And so they really want you to get some, representatives of various cultures involved. And so it's not just one person coming up with some sort of name that will end up being the case, which, it's kind of how I did it. But nonetheless, that those are the ground rules. So if you really need to look at those ground rules and you're interested, there's a form you have to fill out at the IAU web pages, and I think it's due sometime in early November. And so you can get your team together. And so our astronomy club or group here is currently coming up with some good ideas for that particular system. And I think we've got another one that we're looking at in a different constellation as well.
That's so cool and an amazing opportunity. And I love how they're trying to tie it to some more cultural significance as well. Because we have a lot of constellations that have very strong myths, and some do not have some myths. I believe there is a unicorn constellation. It is not called the Unicorn Constellation. However, there is a unicorn one, and it doesn't have a really strong myth or culture really connected to it. It actually has a lot of theories as to why it exists and why it's a unicorn. So it's actually kind of nice that we're kind of branching out and trying to tie some more names to other cultures as well. It's a very beautiful thing. It's nice. So let's see here. We have some more to talk about today, aside from just that one exoplanet. We have some other stuff, but we're going to spin towards the north. So we're going to shake the world a little bit. We can spin around on Earth. We can as humans, however. What? So let me try something really quick. I'm going to experiment here. There we go. They're back. I don't know why they disappeared earlier. I just am not. I don't know what it is, man. Stellarium just really doesn't like me. I don't understand. But they're back.
So one episode it's the ground, and the next one it's the sky?
Yes, and I don't know why, but I brought them back without much struggle. We love that. So here we are in the north now. We are facing north. So what is so special in the north? Can anyone on my crew tell me?
Well, I'm seeing I think I see a pot right in front of us.
A pot?
Do you see the pot?
The Big Dipper?
Yep.
There we go.
Yeah.
Very nice. The Big Dipper. So what can you tell us, Kenya?
Yeah.
Thank you, Kyree, for telling us what the Big Dipper is.
Yeah, thank you, Kyree. So this image that's made up of stars, many people recognize as the Big Dipper. Some people, though, like including myself until recently, might consider the Big Dipper a constellation, but that's technically not the correct term for it. Instead, we call the Big Dipper an asterism. And an asterism is like a familiar pattern or group of stars that people recognize, but it's usually smaller than a constellation. So the Big Dipper, for example, is actually part of a larger constellation that is called Ursa Major. And Ursa Major's Latin name means greater bear. So although it may be hard to picture at first, it is supposed to look like a bear, as you can see. And then so you might think back to maybe like the Little Dipper, and that would be like the lesser bear of that constellation. But anyways, so the Big Dipper is pretty difficult to find in the sky tonight because this time of year after sunset, the constellation is very low in the northeastern sky.
Yeah. Lots of trees.
So usually there's like trees or other things that are like causing you not to be able to see it. But I guess one last thing that I'll mention about the Big Dipper is that it can be used to find many other constellations, and including one that our friend Kyree will talk to us about now.
Cool. Always love the Big Dipper. Before we go into the next constellation, I have a task for my viewers. My passion for astronomy started when I was very young, and one of the memories I have is that my sister used to read to me every night and read me a book about the Big Bear, which was all about Ursa Major and the Big Dipper and the Little Dipper, Little Bear. It was a book, and you pushed a button, and it lit up the constellation, Big Bear and Little Bear, for you. I don't remember the title. It's a children's book. If you could comment down below if you know what that book is, I would really appreciate that. I have been on the search for many Constellation Crew episodes. I bring it up a lot. It's a very strong piece of my heart and memory, but for some reason it's not in my house, and I would like to know where it is so I can get it for nostalgia. Back
That
to the
sounds
actual...
like a really cute book.
Isn't it? It's so cute. And it was all about, like, bringing the Big Bear and Little Bear to life. Like, it was still astronomy related, and it lit up in the book, and it was cute, but it was very Big Bear and Little Bear focused. But it was one of my favorite books as a kid, and I always loved the end where you got to push the button and light up the constellation. It was quite beautiful. But back to astronomy. Kyree, we were looking for a certain constellation.
Yes, we are actually looking for the Canes Venatici, which is somewhere near the handle of the Big Dipper.
Handle?
Should believe it should be a bit more south.
Might need to go. Is it this star behind this tree here? Let's click on it. No, it is not. But how about we do what I always default to, and that is looking it up. Make sure our cursor is in the box. Because, again, I never do that correctly. Oh, look at it. There it is. I have to type the full name in order to go to where we need to go. Oh, it's right there. Wow. So that's what he was talking about. So you have the handle here. This is still the Big Dipper. Little handle. And you go from the handle straight down to that tiny little star there.
Yep.
And that's where it'll be, in the northwest sky. Tiny little star.
So yeah, it'll be higher in the sky, 6 months from now.
Okay.
At this time, right?
Yeah, that is good to know. In Stellarium and any planetarium, we have the ability of fast forwarding or going backwards in time. For now, though, we can probably just hang out with the trees with our two little dogs here, because we're just gonna briefly mention a couple of things about it. So, Kyree, anything else about this constellation?
Well, as you already preluded to it, these are two dogs, known as the hunting dogs in Latin, given their names by Avelius in, I want to say, around 1687. The northern dog should be named Asterion, and the southern dog being named Kara. It's honestly just a really cute constellation. To stray away a bit from exoplanets, or you can the Whirlpool Galaxy actually lies within that constellation, which is a spiral galaxy. A lot of really fun stuff about it. A really cool galaxy in general. I enjoy looking at it, but of course, this keep on track. I won't talk too much about it. But as we already said, you can see it right under the Big Dipper asterism. It may be a bit hard to see because it's really, really north. And as Vaccaro talked about earlier, we will be able to see it probably months later down the line. But for now, it'll chill right near the trees like we were talking about. So I would actually like to bring it on to something else that can be found within the Canes Venatici constellation. So Nicolette, do you have any information for us about that?
I do. We're going back to my favorite topic again, and we're going to bring up the Astronomy Club again. So we are going to be talking about an exoplanet called HAT P12b. Awesome. So very much like the last exoplanet, it's another gas giant that is very close to its host star and is known as a hot Jupiter in exoplanet terms. So the reason why it's called a hot Jupiter is because, like I said earlier, it's a gassy giant, but it is very close to its host star, very abnormal. We talked about that earlier, where it should be forming further away from its star and stay out there. But like Dr. Vaccaro said, sometimes planets, as they're moving around or just trying to do their normal thing, one planet may be starting to fight and something happens and it goes really close to its host star, and now it's a very hot gas giant instead of a cold gas giant. So it is about... it takes about 3.2 days for it to complete an orbit around its star. So we had 7 before. Now we have 3.2. So it is really fast. And just imagine. So I do have the mass here, and it is 0.211 Jupiter masses. That's a strange term. So Jupiter masses means that it takes the mass of the planet, whatever that may be, and divide it by the Jupiter mass, I believe, in order to give it more of a ratio number. So kind of think about it this way. When I say it's 0.211 Jupiter masses, that means it's about 0.2 less than Jupiter's mass. Is that a correct way of describing it, Dr. Vaccaro?
I would just basically say it's like 21% Jupiter's mass.
Okay, that's I like that a lot better as well. That's very nice. So yeah, it's about 21% of Jupiter's mass. So it's around the same family, which is why Jupiter masses can be important in astronomy instead of using these really, really big numbers. And then when we're dealing with something so small, the number is way, 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 way small. Now we can put it in terms of numbers that we actually understand by comparing it to something of similar mass. So it's about the same as Jupiter, give or take, but it's all the way right by its host star. Don't know why though. It's always a mystery. Sometimes maybe we can discover that someday, or I would like to go into exoplanet research. Maybe it'll be me. Who knows?
So what was that one called again?
It was called HAT P12b.
Right.
So
it's another candidate, right?
Okay, that was just about what I was going to ask. Is this another candidate in your group?
Mm-hmm. Yeah, this is another one of those Name ExoWorlds 2022 candidates that we've been thinking about. And so I think we're coming up with some good ideas with our team, and we hope to submit something on one of these in the next month or so.
Wow. That's just still so mind-blowing that there is something on campus like that we can all be a part of. And if I remember correctly, you don't need to be an astronomy major or minor to be a part of astronomy club, right? As long as you have a strong passion for it, or a passion for it.
I mean, this is one activity, and it's an opportune activity at this potential time. They don't do these contests every year. Mm-hmm. If you look back at the history, they've done it in 2015, 2019, and now 2022. If you look at a list of exoplanets that have been discovered up till this point, there are several thousand easily. Mm-hmm. And so they could do this type of contest for quite a while, and just repeat it on almost an annual basis if they really wanted to. The IAU probably is a little busy, not wanting to do that every single year. And, it takes a little bit of organization, but it does give people an opportunity to get involved and not have any science background whatsoever, and our club tries to do stuff like that. We do basic observations with telescopes. We can take telescopes out. We've had a presentation some years ago, Nicolette, that you were part of. I think this was prior to Constellation Crew, when we talked about Radio Jove,
yes,
for example, and that's radio observations of Jupiter itself. Mm-hmm. And so we've got an instrument that we can do that. And sometimes we just like to have fun, right? We'll have movie night in the planetarium, or the DART mission, the old planetarium, and have pizza parties and do a lot of fun stuff. So it's not like a academic club per se. It's not even a formal club at the university in that sense. So it's a much more casual group, and we encourage students to participate as much as they can. And so we'd like more people to chime in on some of these objects and give us some ideas of what they have for names. That's part of the team's job, is to discuss potential names and finally fill out that form and submit it and say, hey, this is what our group has recommended, and see if we get something named that we got to pick.
Exactly, yeah. So that being said, feel free, viewers, to comment down below anything that you feel would be cool to name an exoplanet after. We also are going to be putting the link to the website that Dr. Vaccaro referenced earlier somewhere at some point, either in the comment section, description, or during this video. Feel free to check it out, take a look at the rules, have some fun with it. You know, we really would like your involvement if you so choose to comment, and comment in general on this video. What did you like about it? What's something new that you've learned? We love to hear when someone discovered something new during Constellation Crew, because that's the whole point. We want to talk about astronomy with you all and learn something new together. That's the whole point. Aside from that, here at the Planetarium, we have some new planetarium shows in rotation, one of them being the Halloween program. It's one of my personal favorites. I got to watch it in an astronomy class once for just a really fun, maybe it was before fall break or something. It was our last class in the week, and it was just amazing to see for the first time and amazing to see again and again and again. I highly recommend. We also have an Eclipse program about eclipses, what about them, and some safety viewing procedures of watching an eclipse and stuff like that. Fun fact, eclipses happen on the ecliptic. Haha, fun names. We love names. So feel free to stop by at the Planetarium this Friday or Saturday during our regular show hours. Feel free to check out the website for those. And of course, we do have our social media to keep in touch with the Planetarium and anything that we plan to do. Is there anything else, crew, that you would like to talk about before we go?
I can't think of anything.
All right.
Nothing can I?
Really quickly, I am very excited about this naming process because I don't know about you all and viewers, I am getting real tired of seeing a list of numbers for things. Especially when some of these planets or stars have numbers that are about, I don't know, and like they form a number a million, so that would be six numbers, 6 digits long. Yeah, no. But thank you all so much for participating in Constellation Crew today, and we hope to see you next time. Bye, guys.
All right. Thanks for having me.
Of course.
Of course.
Thank you for coming.